Hi guys, hope you did. You're fine. Again, me, and we are gonna talk about the last part of momentum, the rockets and jets. As you see that there is the balloon here, and it is inflated balloon, and when we release that inflated balloon, the open neck, as you see that here, and that time you see that the gas inside the balloon, the air is moving in this direction and with the speed, and after that the balloon is gonna move in opposite direction. As you see that if you release an inflated balloon with its neck open, it flies off in the opposite direction to that of the escaping air. This is the similar like explosion. As you remember that in the explosion we were saying that the object is at rest on the ground, as you see that, and it's explode inside and there become two pieces. Think about that. And if the one piece is moving in this direction, the other piece should move opposite direction, and at the beginning at the momentum was the zero. In after explosion the total momentum should be zero also, isn't it? If we say that P1 this and the P2 this, the total momentum equals P1 plus P2 and the vector, and it should be zero. Those momentums should be equal but opposite. It is similar issue, similar idea when we can talk about the inflated balloon. As you see that there is the momentum of the gas, the air has the momentum to the left. As you see that the air has momentum to the left, P air we can say that, and the balloon moves the right with the equal momentum. Balloon will have the opposite direction with the equal momentum. The total momentum will be zero again. We can say that the total momentum it's gonna be zero because at the beginning there was no any momentum. Initial momentum was zero. The total momentum equals air momentum plus balloon momentum, we can say that, and those are the vector quantities. If we have the opposite direction, the same amount, same magnitude but opposite direction, two vectors, air and then the balloon, the total momentum is gonna be zero, as you see that. Okay, this is our main idea about the rocket and jets. Inside the rocket, inside the jets, there is the gas, there is the some explosion, and one side the gas is moving with the very fast, very high speed, very high velocity, and that velocity is make the rocket and jets move forward. Okay, this is the principle of rocket and jet engines. As you see, look at here, as you see, this is the jet engine. Inside the jet engine, how it's work, as you see that here the air is entering from this direction, and here this is the air and the fuel is combined, and there is the explosion here, and the gas is moving in this direction with the very high speed, and here is the gas momentum. That gas momentum is make the engine pushed forward. As you see that engine pushed forward, and then it is making movement. The engine is gonna move in this direction, as you see here. Yeah, this is the main idea about the rocket and jet engines. We have one question here. A rocket of mass 10,000 kg uses 5 kg of fuel and oxygen to produce exhaust gases ejected at 500 meter per second. As you see, it is very high speed, it is very high velocity. Calculate the increase in its velocity. Okay, let's draw the one rocket here. Think about this is the rocket, and then here the gases are going outside with the 500,000 meter per second, and with each second they are using the 5 kilogram of fuel and oxygen, and the mass of the gas is the 5 kilogram. The saying that what is the increase the velocity, increasing the rocket velocity. Here it is main idea, it should be there is one the gas momentum, and the opposite side there should be the rocket momentum. Okay, and those are should be equal. The gas momentum is equal to opposite, meaning that negative the rocket momentum. What is the gas momentum? The mass gas times velocity gas equals mass of the rocket times velocity of the rocket. Okay, each second we are gonna find how many meter per second the rocket velocity will increase. The mass of the gas is given 5 kilogram, and the velocity of the gas is given 5,000 meter per second equals mass of the rocket is given 10,000 kilogram. As you say, it is already given kilogram, we don't need to convert anything. The velocity is already given meter per second, we don't need to convert anything. Okay, about the units we have to be very careful. If we reorganize again that equation, rocket velocity will be 5 times 5,000 over 10,000. As you see that the rocket velocity will be 2.5 meter per second, meaning that in this second, in that second, in this time, the rocket velocity will increase 2.5 meter per second. Every second, think about the gas is making that impulse, and that impulse is making the rocket forward, and each second the rocket velocity will increase. Okay, this is our answer. Calculate the increase in its velocity, meaning that rocket velocity will increase 2.5 meter per second in that time. Okay guys, thank you very much. We finished the momentum here, and we will continue with the next chapter.